What do you want? Yes, it's true. You want to have a look? Okay, just stay there, you're not coming in. Do you believe me now? Blackface Princeton non-reverb, my favourite. Okay? Okay, this is a 110 volt unit, so I've got it in my step-down transformer. And the fault that was described was there was a hum and low clean headroom that was distorting very early on. Okay, this is what's on the speaker of the Princeton with the volume off with an instrument plugged in. I don't know if you can read that, but that's the waveform. It's not very high, but it's probably the hum we're hearing. I don't know if you can see that frequency, but it's flicking around 100 Hertz back to 50 Hertz. So 50 Hertz would be telling me it's something like an earth issue. 100 Hertz is telling me that it's more than likely the filter caps that are going. 100 Hertz is rectified, full rectified AC. So I think we'll start by having a look at those filter caps and the earth connections. Wow, this is looking better and better all the time. It's looking very original here. We've got original RCA 5Y3, a couple of RCA 6V6s, original speaker, and I suspect lurking back here as part of our problem, it's the original Astron multi-cap, multi-section capacitor can. I think I've got a few more of those in stock. What have we got in here? All lovely original tubes, which I'll check all of these. Hopefully they're all in good spec and these are still well matched and strong, in which case we'll keep as much original as we absolutely can. He's a gigging musician, so we have to make it reliable. Wow, this is looking very original, probably too original to be a reliable, quiet gigging amp. So let's start. I'll get it on the bench and we'll have a look at it. The original old Malloy caps, these beautiful blue, another, can you see that one there? That's the bias cap. Another one of these beautiful brown paper ones. There's the notorious death cap. Where is that? Can you see that? There we go. I'll just remove that. And this has got a 2-pin USA lead. So another job will be to replace that with a 3-pin. It's interesting how things evolve as you get into a repair. I'll just show you what I've done. So replace the cap can. I had another couple in stock. I decided to leave the death cap in there for originality's sake, but the switch is totally disabled now. It's got a big crack in it. That's a 1K 1 watt. So I'm going to replace that with a 3 watt. I think that is. The Princetons were 6G2, which is basically brown face. You know, definitely my favourite era of Fender amps. And this is that death cap that's going to come out now. As you can see, it can be switched between either one of those two phases. It's just 2-pin, no worth there. And in theory, it works fine. You know, if there's any noise on one of the lines, it'll shunt it to the chassis. Problem is, if that gets a short in it, then we're going to have 110 volts or 240 volts, depending on how you've got this thing wired up. That's going to now go to the chassis. You touch that chassis and you're going to know about it big time. So the look of them, but these are just got to go. And these are the cathode bypass caps on the preamp tubes. That's the bias filter. So, see you fellas, you can stay in a spare parts bag for the future owner, but this guy needs to play. Okay, we've done the bias filter cap. and the cathode bypass capacitors. I think I'm still a bit suspicious about these. These are the final coupling caps. Where are they? I'm not sure if you can see this, but that's these two here. If these things leak into the grid, it's going to, well, play havoc with our power tubes. So here's the bias voltage coming in, there's the tremolo, which is basically adjusting the bias on the run, turn the thing off and back on again. But if these things leak, we've got a problem. I love the look of them, and I'm going to try and keep them, but I think what I'll do is I'll pop one out, put it on my capacitor tester. If it's leaked, or if it's drifted way far off its 0.1 microfarad, I'll change them. Well, what do you think about that? I reckon that capacitor's right to go for another innings. I'm happy to be able to keep as many original parts as I can. That's still well within spec. Okay, let's just make sure that these input sockets are clean, because they can certainly add to the noise if they're not. Just file that little earthing switch. And the other one. Yep. There's good spring tension there. We don't need to adjust anything there. No one ever thinks about cleaning them. This is obviously the one he uses the most. What do you reckon? Just apply a little bit of the magic compound, bit of deoxit. It's expensive, but it's a great little, expensive in Australia anyway, but a great product for improving contact. What's that? I let you in here and now you abuse me? You think I look like a dick because I wear earmuffs when I'm blowing out the pots? I don't care what I look like. At least I can't hear you now. I think we're getting close. I've done hopefully all the replacements and upgrades and repairs that are needed doing. So now I'm going to start bringing up the voltage very slowly on my Variac. I'm measuring the filament voltage, so I should see 6.3 volts here by the time I'm on 240 volts there. So take this up slowly, give those capacitors a chance to get their charge. Okay, so I'm going to call that at 240 volts. We've got a filament voltage of 6.5. I'm really happy with that. Let's just have a quick measure around here. That's good. Minus 34. Plate should be the same. 395. That's spot on spec. High, but I think I will put my less, maybe 350 bias checker on it and just see what current we are drawing on these two. But before that, I'll just test to see that they're okay on the maxi matcher, and we'll go from there. But so far, it's looking really good. That hum that I was hearing before is gone. Sometimes I just never fail to be amazed at the quality of what those old American valves were. I just did a silver tone a few weeks ago. 50-year-old tubes, still strong, still well matched. Just amazing. Let's see how these are going. These are a couple of RCAs. So first thing we're going to measure is the plate current. So we want to see over 15 milliamps, and we're not quite getting there on that one. Yeah, okay. I mean, I work on 10% as a figure I've come up with. If they're within 10%, that's near enough for me, but that's a long way out. Ignoring the fact that they are so far apart, you're never going to get a good clean signal. Okay, let's see what our transconductance is. It's basically the gain. Likewise, I'd like to see over 3,000. This times 1,000. So I think we can pretty much definitely say that tube 1 is for the display cabinet. Yeah, even this is weak. Should be over 3,000. Sad news for the customer. I was hopeful that those beautiful tubes would still be okay, but sadly, no. Of course, I've got all the modern manufactured ones, but I think this amp might be worthy of these. They're new old stock, as you can see, in box, unopened, but they're Russian military. So I'm going to whack a pair of these into the Maxi Matcher and see how these line up. Drum roll, please, ladies and gentlemen. Okay, I'm really happy with that. This is a very good matched set. So that's 3250. Man, they are so close it could be the same tube measured twice. Alright, really happy about that. I've tried these before in my Princeton actually. I've got a 68 drip edge, and these tubes sound phenomenal. So I think the customer will be very happy with these. Now that we've got two known good tubes in there, I expect that they'll be drawing a little bit more current. So our 390 volt plate voltage that we measured before, I expect that to drop down a little bit more. So here we've got our plate voltage when I turn the amp on, and here we've got the current going through each tube, and I dial in which tube I want to look at through my little device here. Goes right up. Now I expect this to slowly come down as those tubes start to turn on. Perfectly. It's not quite like paint drying. I find it actually very interesting. Okay, so let's have a look and see. So we're drawing 24 milliamps through one of those tubes, the one closest to the phase inverter. I'm going to switch over to the other one, and it's 21.5. Now when the tubes were so well matched, why is there a discrepancy? More than likely the windings of the secondary transformer are not matched. So what I would do at this stage is I will switch those two tubes around and measure the currents again. First orientation, switch positions, so much closer. So I'm now going to mark those tubes so that they go back in that right place. And if we measured the primary side of our output transformer, I'm not sure what words came out of my mouth before, but that's what I meant to say. I think we'd find that they were probably not as well matched as what they could be. But this is definitely a very acceptable match. But there's our basic bias supply, which is -35, which is very close to what we had. And it's here, so a little potential divider here. So even though there's no bias control, I can frig around with this resistor value here. Let's just see how close we are. So a 6v6 tube is nominally 12 watts max. So we've got 364 volts by 0.0229, which is 22.9 milliamps, which is 8.3 watts. Divide that by 12. So we're at about 69%, call it 70%, which is pretty much smack in the range. I'd go anywhere from 55 to 70%. Slightly warmer, but it's not a bad thing because we've put in a whole bunch of new caps, so I don't want the owner to find it too stiff sounding, so having it a bit warmer will be closer to the sound that he's used to. And you know, maybe next year when he brings it back in for a checkup, or as he does this one every 50 years, whether it needs it or not, I can rebias it then to a slightly lower level, but I'm quite happy with that. So I've got about 100 millivolts going in it at 1 kilohertz, so we should see that read 1 kilohertz pretty soon. And we're going to be reading peak to peak and also the all-important RMS, and we'll just see what this little fella can put out now. And we'll see where it starts to clip. Look at that, beautiful and clean. That's up to about volume 5. It's about 7. Okay, just starting to see it going off a little, I think. Okay, here we go. So we're seeing clipping, top and bottom, or saturation and cut off. So we're going to call that the level, which is, we're going to call it 11 volts RMS. So 11 squared divide by 8 ohms, 15 watts. That's pretty smack on. In fact, it's probably a little bit better. All of these cup washers were missing. Forgot to tell you, when I started, I had to listen to it, and it was distorting badly on around about volume 2. By 3 it was just shocking. I think we've got it sorted. I'm keen to hear this. I've got it on volume 4, tones on about 7, vibratos off. Sounds better than my Princeton.